be back. I think this is my third time now speaking at Code Harbour. I think I did one in person and just right before the pandemic actually, last time, and then one online, and then it's really good to be back in person actually doing a talk to people rather than just faces. And lovely venue as well. I actually haven't been up here before, so really lovely. I'm Rebecca. I'm the lead data scientist at EDF. I've worked in data science for I don't know, sort of 6-7 years. I used to work for Holiday, which is actually a local company, probably some of you know about, and then moved to EDF about a year ago. Today I'm going to talk about data quality for data science. So, you can't have data science without data, and you definitely can't have data science without good quality data. And to be honest, I don't think data quality is something that's talked about a lot in relation to data science. So I thought, and it's something I'm working on quite a lot at the moment, so I thought I'd do a talk about it. So I'm going to kind of talk about, I'm going to cover what data quality is, I'm going to cover a bit about what data science is, and I'm going to talk about how data quality kind of relates specifically to data science as well. So to start with, I'm sure most people have probably heard of sort of this kind of phrase used about data before. Has anyone not heard this garbage in, garbage out phrase before? I don't think so. It's often said, but it is true. If you put rubbish data into anything, to be honest, including data science, you just get rubbish out. So data quality is really important. So I'm going to start with what data quality actually is in a general way. So generally speaking, data quality at a broad level is usually described by kind of 3 dimensions, which are shown here. So you've got data correctness, which is all about how well data reflects reality effectively. So if you have a source system of some kind, producing some data, does the data reflect what actually happened in that source system? Freshness is all about how up-to-date the data is. So if you expect your data to be available on a daily basis, if it's not available on a daily basis, then it's not fresh and it's not good quality data. And then you have completeness. So how complete is data? Is there anything missing? Are the values missing, or whole columns of data missing, or entire pieces of data missing? And that's another measure of data quality. So that's what data quality is. So what is data science? So data science has it's actually been around for quite a long time, but in terms of data science in business, probably it's emerged in the last couple of decades really, and it's come about from the fact that businesses have started to collect more and more greater volumes of data, and collecting data and storing data has a cost, and so there has become this kind of desire to get more and more value out of that data, so value beyond what usual kind of reporting or analytics can deliver. And so data science is what has emerged from that. Data scientists use some traditional skills, so the maths and statistics behind data science have been around for a very long time. It's not new, but what is new is combining that with computer programming and big data processing, basically, so that you can basically run these kind of large, maths and statistics on really large volumes of data. And ultimately the goal of data science is to get some value of some kind from that data. So in terms of data, so I've talked about data quality, I've talked about what data science is, and then one thing to probably cover is where does data quality issues generally speaking occur? So again, this is kind of generally speaking. There are not three places in isolation, but 3 sort of areas where data quality issues tend to occur. So the first is in source systems. So source systems is obviously where you get your data from originally. Errors can occur, if something goes wrong with the system, you can get a data quality issue. If you are collecting those data in the actual collection of the data from the source systems, you can get errors. Another place where data quality issues occur is in the processing of data. So anytime you're processing anything, transforming that data or changing it in some way, there is a chance of an error occurring in some way. And then storage. So when we store the data, quite often we are storing it on a regular basis. So we might be storing it every day, every minute, or every second. Things could go wrong with the storage. You could miss whole days worth of data, or individual data points might not load. So that's another place where you can get data quality issues. But when we bring data science into things, it can get a little bit more complicated. Now, when generally speaking, one of the cornerstones of data science is machine learning. So when I'm talking about kind of where data quality issues can occur with data science, I'm focusing a lot on machine learning actually. So data quality issues can get, as I say, a little bit more complex when it comes to data science, and that's because you'll have your usual, so in any kind of organisation where you're collecting data and storing data, you'll usually have usually a central place where you store your data for things like reporting, analytics, and data science. And as we've already said, you get data quality issues kind of at collection, when you're processing it, when you're initially storing it. But with data science, especially machine learning, we always have to process that data further. And that's because machine learning, as I mentioned earlier on, machine learning works from maths basically, so it's kind of mathematical computations. And as a result of that, the data has to be numerical. So that's one area where we might process the data. So we might have data that's like a string, but we'll have to turn that into a number before we can actually use it in our model. And we'll have to do processing beyond that as well. So we do things called feature engineering, so we might change values in some way so that the model can better kind of find patterns in that data. But either way, effectively data science has to do their own processing on top of any other type of processing that might happen. So obviously you'll have a chance where you could introduce data quality issues there. The other thing that further complicates machine learning, especially, is that machine learning models, we use historical data, so we get some historical data, we process it, and then we use that data to train a model initially. But what we actually want to do is kind of predict the future. So then what we want to be able to do with that model is we want to take some new data, so we want to go back to kind of this first storage, we want to take some new data, and we want to run the model against that data to generate some predictions on that new data. Now obviously, in order to make those predictions correctly, that new data has got to be processed in exactly the same way as the initial data that was used to train it. And so it needs to have the same level of quality, and it also has to need to have the same processing. So you almost have two kind of states where you need to maintain data quality beyond what the business or what the rest of the organisation might have. So data quality for data science is often a bit different to other types of uses of data, like analytics, general analytics reporting, and that's for a few different reasons. Some of them are on this slide. So one is that machine learning is all about learning very general concepts from very specific examples. So you have individual rows of data, and your machine learning model is trying to learn general patterns from that data, so it can use those general patterns to make predictions on more individual rows of data. But the key takeaway, I guess, from the first point is that the precision of data quality for data science has got to be at the row level, so it can't be an aggregate, it's got to be at the row level. The other thing, which I've just mentioned, is that with machine learning, we have some historical data that we use initially, and then we need to create predictions on new data. So data quality in data science has to be preserved over time, so we have to make sure that we're maintaining consistency of the data quality. And that's really important. And the third thing is that data science outcomes directly affect people. So data science and machine learning in particular is often used in automated systems. So if you think about something like a recommendation system, so I'm sure everyone in the room watches Netflix, for example. I doubt anyone doesn't. So Netflix, obviously, very large streaming app. They have thousands and thousands of movies, TV programs, and so on. You know, basically, if you're a user of that, if you want to find something new, you would, you know, ordinarily have to sift through potentially thousands of different things. You might not be able to find anything you want to watch. With Netflix, it uses recommendation engines that use machine learning to predict what the machine thinks that you are going to want to watch next, and so you can sort of filter those TV programs for you. And that's how that works. And that's an automated process, so it's just automatically going to be doing that all the time. And so obviously Netflix is quite a benign example of things that could affect a person, but a lot of machine learning is used in that way, and other types of machine learning could, you know, where it's used for automated decisions, could have more of an impact. And that's kind of shown here. So bias is a really, really key element in data science, machine learning, and AI that we need to check for. So it's something that it is, I think, a type of data quality that we need to check for as well, and it's on top of other types of data quality that we might check for in, you know, other data uses, and this is just an example of lots of headlines that have made the news about examples of bias occurring in AI. So it's something we need to be careful of. And another thing, just to mention, which is really important actually, and goes into some of the next slides that I'm going to talk about, is that errors in machine learning systems often fail silently. So in traditional computer programming, if we get an error in our code, it will usually fail in some way and give us an error. But in machine learning, what happens is it won't necessarily fail, it will just give us basically the wrong, misleading conclusions and decisions. So that's one of the other key important things about machine learning. And this slide kind of illustrates that difference. So this is showing kind of what machine learning does versus traditional computer programming. So in traditional programming, we feed in not always data, but sometimes data, and we write the rules in order to get our answers out, so we write them. And the important thing is that rules could be tested, we can write unit tests and things like that for our code in those rules, and if they fail, then we know something's gone wrong. In machine learning, it's a little bit different. In machine learning, we feed in some data, and we feed in the answers we want to get from that data. And what we want to get out of the machine learning model is a set of rules that we can then use again to get more answers out of some new data. And we can't write tests. We haven't written those rules, so we can't really write tests for them in the traditional sense. So actually, what we're relying on is the data to be correct. So we need to make sure that that's correct, which is why data quality is so important. So that's kind of a problem statement. What's the solution? So one solution which has come around in probably only the last couple of years actually, it's quite new idea, is what is sometimes called data quality unit tests. And they're not quite unit tests, not quite the same thing, but I think in terms of finding a concept that's similar to what we're doing here, unit tests are probably the best description of that. So there are lots of open source tools that have been developed probably over the last couple of years that enable you to write these sorts of data quality unit tests. One library that I'm going to introduce just to talk over is one that I've been kind of working with very recently actually. It's called Great Expectations, and in Great Expectations, the library, they call the data quality unit tests expectations rather than unit tests, which I actually think is probably a better description. So effectively what you're doing here is you're looking at your data. Once you've cleaned it, you're absolutely sure of the quality of that data. You then create some expectations about what you expect that data to kind of look like. And then what you can do is use those a bit like with a unit test. You can run them on new data to check that the data conforms and that there isn't an error. So how could we use that in the example that I sort of showed earlier on? So what you would do is you would, where we're kind of doing our additional processing of the data, we'll do our processing of the data, guess it exactly how we need it to train our model. That's the historic data, so we create our expectations from that data. So that's, creating our set of tests effectively as to what that data we expect it to look like. And then when we get our new data in to use with our model, we can validate that data with our expectations before it gets to the predictions. And so we know that the quality of the data at this point here, when our model's creating its rules, is good quality, and hopefully nothing will go wrong. So as I said, this is the library called Great Expectations, which is just one open source library. Actually, there are a few others. There's a slide at the end which shows a few of the others. Great Expectations, really good. Like I said, I haven't been working very long, but really good library. It does a lot of, it's very automated and does a lot of things, really well. So it takes effectively any of your data, so in numerous formats. And it basically creates the expectations. It also creates lots of documentation, and you can also use it for like logging and alerting as well to data quality issues. But importantly, it allows you to build, high quality data products because you've got high quality data. So, kind of how does it work? So, what Great Expectations does is it has a tool called a profiler. So what you do is you get your data, as I say, when you're happy with what your data should look like, and you run the profiler on that data, and it will look at these things basically. So it'll look at things like some simple statistics, simple script statistics, like what should be the mean of this column, what's the minimum value we would expect versus the maximum value, what's data types, are there null values and so on, and it will generate some expectations or tests effectively you can rerun based on some of these attributes. So when we went, if you think back to the beginning of this talk, I had a slide that said what is data quality, and it had 3 boxes on it. This is probably the dimensions, might not be everything, but the high, broad level dimensions for data quality, I guess, for data science specifically. So we talked about bias and fairness early on, so that's an important one. Outliers obviously is about extreme values that we shouldn't expect in our data. Missing data is really important. Erroneous data, so data that is wrong, it's not as we would expect. For example, if we had a column that had colours in it and it was like red, green, yellow, and suddenly we had the word cat in there, then that would be wrong, would be an error. And we have drift. Drift is kind of about preserving that data quality over time. So with data, at a point in time when we collect it to begin with, it might be good quality, or it might be a certain level of quality, but over time, we can get errors introduced over time, and that's what drift refers to. So it's sort of the change of data quality over time. So the Great Expectations library, as I talked about earlier on, covers nearly all of these, except for bias and fairness. And so when I was looking at Great Expectations, bias and fairness I think is key, really, really crucial for data science. So I had to look to see if there was something else that had that. And there is another library, actually, which is another open source library called Y Data Quality. So this actually integrates as well with Great Expectations, which is really handy. So yeah, really nice library. And what this has, in addition to all of the Great Expectations that you can integrate into this library, it also has bias and fairness profiling. So what this will do is you take your data, and if you've got any columns where you think bias could be a problem. So obviously in society we unfortunately do have biases, but we don't want to propagate those into our machine learning models. So if we have something like gender or race or something like that, where we think there could be some bias, then what we'll do is feed those columns in, and then what the library will do is have a look for things like, is the representation good enough for each of the values in those columns and things like that, and it'll look for problematic correlations, that kind of thing. So it's a really good one way anyway of trying to sort of prevent bias from creeping into your models. So as I said, it's integrated with the data expectations, the Great Expectations libraries, and it's so yes, this is what it looks like when it's integrated. It's exactly the same interface as the other parts of Y Data Quality library, but with the Great Expectations test that we talked about earlier on. So as I said, Great Expectations is one open source library that I've found so far. There are others that are emerging that do different things, and they all kind of have slightly different levels of support or things that they do. As data scientists, generally speaking, Python is the most popular language for data science these days. Pandas and Spark are probably the most common data manipulation tools. And some people, I personally use a mixture of both Pandas and Spark. Some people might prefer one over the other. So this kind of just illustrates some of those differences. The blog post linked at the bottom there is where this actually came from. It's a really, really good blog post. It details these libraries basically and does a big comparison of them. And then this is a really, really nice checkbox at the end, which tells you kind of the pros and cons, I guess, of each of them. Yeah, so that's kind of quite close to the end of the talk. But just to recap what sort of I've talked about. So yeah, data science requires specific dimensions of data quality that might be different to other use cases of data, as we've talked about. And that's because the rules that we get, so the machine learning model is writing the rules, and we can't test the rules, so we have to test the data. That's what we have to do. Expectations or Great Expectations is one solution, but there are others out there. I'm still having a look at the other options. And yeah, there's a great ecosystem of open source tools actually being developed for data quality, for data science, and particularly automated is a really big, important one, because we're obviously in a lot of cases creating machine learning models that are automatically generated predictions. So them being automated so they prevent errors before they get to the model is really important. So yeah, thanks for listening, and I think we've probably got a couple of minutes for questions still, if anyone has questions. Okay, great. Any questions?
With bias and fairness,
Yes.
Sorry, just trying to think how to sort of phrase the question. So if you take gender, for example,
Yeah.
What am I trying to ask? Isn't it just, why would you factor that out? Or why would, because it seems that surely if you include it, then it is a real thing.
Yeah, it is a real thing, but it's not as what we want to propagate. So it's a really, really good question. So I'll give you an example of where something's gone wrong in relation to gender in particular. So a few years ago, Amazon created an automatic algorithm for sorting CVs for recruitment. Now, actually, Alex and I were just having a conversation about the fact that women are vastly underrepresented in tech roles. So what the algorithm learned was that if there was anything related, and actually they stripped the CVs of anything that should really tell you that it's a woman. So, for example, Miss or something as a title. But what they found was that if they had, say, a college, they'd gone to a college that was a women-only college, it would pick up the pattern that was, where women came from, and the fact that women were underrepresented vastly in the data that was kind of, the machine learning model was learning from. It propagated that bias, so it filtered out all female CVs, and so actually what it did was promote the male CVs because that was the bias of what was successful in the past, if you see what I mean. Right. So that's a really good example of why we might, although that's reflective of reality, which is completely true and a very fair thing to say, although those biases sometimes exist in society, we don't really necessarily always want to propagate them through into a model, particularly that's making decisions. So that's just one example. There's loads of other examples where things like that have gone really, really wrong, actually. So does that answer your question?
Yes, that's
great. Any other questions? Yes.
How much is machine learning responsible for bias?
Well, that's another good question. So I don't think machine learning is responsible for bias. I think the people who are almost like steering machine learning are responsible for bias. So, and potentially the data, but that is, I see myself as a data scientist being a bit of a custodian of that. So, if I'm building a model, I've got a responsibility to understand deeply the data that I'm feeding to that model and understand what could go wrong in terms of bias and fairness in that data that I'm putting into that model, and also checking the outputs of that model to check that there's nothing going wrong or being propagating through, which is why that's a big focus when I've been looking at data quality for data science. So I don't think it's machine learning is responsible for that, or it could be if these things were not checked, but it's actually the people who are building these things that who should be responsible, I think.
Sorry, if there's an answer to the question.
Yes.
You said that the stuff that goes into machine learning is, so you have the data and then you have the rules that was traditional. So you have the data and then the answers.
Yes.
What format is like in my mind I'm a programmer, I can picture what data is, and I can picture what rules are.
Yeah.
What are answers?
Yeah, good question. So the answers or rules, or we're talking about the rules that the machine learning model is writing.
I'm particularly interested so answers are an input.
Yes.
What is an answer? So if you've got a set of data, what would be an answer that you'd be looking for from that data?
Yeah. So the answers are effectively like a label of what you're trying to predict. So let's say you had some images of cats and dogs, and you wanted to predict whether they were cats or dogs. The data would be the images, and then the answers would be the labels as to whether the image is a cat or a dog. Right. So those would be the answers. And then the rules are, in machine learning, are basically a set of complex calculations, effectively. Does that make sense? Good. You had a question?
Yes, so you gave an example of Netflix,
yes,
which is a good example, because I've often wondered why But presumably this machine learning is rife, and when you said it affects people, I presume that maybe you could.
It can be used for a lot of good. So yeah, you're right. It can be used in medicine to actually enhance, you know, what we can do to save lives. But things can also go wrong, and so you're absolutely right. That I think it's a great thing. It's a bit like any tool, isn't it? It's in the right hands. It's a good, really good thing. But in the wrong hands, it could be a bad thing. So I think, you know, having and there are a lot. And I mean, the tools I've talked about today about data quality are just some of them. There are other tools that look at evaluating the outputs of machine learning models to check for things like bias and fairness and things like that. So I think that I think it's a really positive thing, but there are you know, we need to be really cautious about how we're using it. I think generally speaking, in my experience anyway, organisations are genuinely very responsible, because otherwise you get those headlines as we've sort of seen. Any other questions? Well, thank you. Thanks very much for listening.